Wow. All right.
I'm on it.
Now, I've never done this on a Mac. In fact, I don't use Macs at all, so this ought to be fun. I'm a Unix guy. Although Macs do have Unix in the background, they cover it with a lot of stuff that I'm just not there. All right. Is he ready? Yay. All right. We're gonna sort of talk about Enfocus and ClojureScript, but this is less about the language and the tools that I'm going to talk about. It's more like the concepts, because I believe that these things can actually be implemented in other languages. I just think they haven't. And some of it's because it's really hard to do some of the stuff, and Clojure makes it very easy to do it. So I am saying that, to me, right now, Clojure is the best language to do this stuff in, by far. But I challenge people to actually attempt to do it in other words, because anything that compiles to JavaScript can do some of this stuff. All right. So this presentation is about developer productivity. It's not really about the language. All right. It's about how do we get the most out of developers. There are certain challenges to being a web developer. It's about separation of concerns, and that's both separation of concerns on the code side and separation of concerns on the actually managing the development. It's about composability, and we'll talk about that a lot as we go through. Clojure, being a functional language, is very composable, and what I'm going to present here today is an architecture that takes that to the next level of using some of the tools to build a composable system. All right. Problem one. First problem we have in web development is this nice, wonderful little problem where this person here is, hold on. Do I have? I do have a pointer. Maybe. This person here, this is our designer. All right. Our designer creates a prototype, passes it to the developer, and the developer then puts code, and somehow it turns out looking like that, which doesn't exactly look like that. And this is the friction that's been there since the early days of the web, is that engineers are not great at design in general. This room is probably full of those that are in that sort of crossover, where they can do both sides. But in a high-performance team, you need experts. You can't be an expert of everything. You need that designer. You need that designer big time. So part of this presentation is about how do we integrate that designer in a way that they control the prototype, but we still get to code, but we're not the in-between. All right. Solution is literally bypassing the fact that it's got to go through the developer. The prototype is inputted into the app the same way the code is inputted into the app. It's that the prototype stays live, and changes to the prototype exist in the app when you make changes. All right, there are solutions to this. Some of you have seen Angular directives. They allow you to sort of separate the thing. What I'm going to show you is a further extension on that, taking that one step further. Tapestry for the Java guys. That's like way back in the back, way long time ago. That was before Angular was Angular. Like Angular, if you look at Angular structure and you look at Tapestry structure, they are very similar. In Clojure, there is a server-side component called enlive. But I believe rendering should happen on the client. So I created Enfocus. And Enfocus was actually built because someone asked the question, how do we integrate the designer? I was actually in a presentation at CinciJS many years ago and doing a presentation, and they asked the simple question of how do we integrate the designer into what I was showing. From that point on, I began obsessed with, I need to figure out how do we actually separate that whole prototyping from the actual development. So, all right. What is Enfocus? It's a library. It's not a framework. It actually can be used a little. It can be used a lot. What I'm going to show you is using it a lot, but I wrote it, so of course. We're going to actually solve several problems. So Enfocus is not the only thing on here. All right, what is it? It's actually a unified API for managing the live DOM inside the browser, remote content, and content you've actually compiled in. jQuery did a really good job of giving us an API to manage the live DOM. But the problem is it's separated from all the external things that we need to manage. And the idea behind InFocus is we can manage that too. I have a compilation phase in ClojureScript. So I can actually bring those into the JavaScript world. What is it? It's similar to jQuery, except it's support for remote and compiled content. There are some differences with jQuery in concept. But the main concept of InFocus is I start with a DOM. All right? Everybody knows what a DOM is. Don't care where it's from. Is it on the live DOM? Can I see it? Can I not see it? I don't care. I then have data. That data could be coming from anywhere. That data is we then use that data, combine it with the DOM to transform into a new DOM object. All right? And this new DOM can be stuck anywhere, but the idea is the combining in. The key here is this DOM is really just data too. And that's a real big difference between Angular and other systems like Tapestry, is that in InFocus, the DOM is as much the data. If we think about the whole prototype is really just another data source to be brought into the app. It can be brought in piecewise. We can take what we want just like we can out of a database, just like we can out of other things. All right, anatomy of a transformation. All right, we have this. We're at some DOM object. We have a selector. Now, selectors, just like jQuery, CSS3 selectors. I also support custom selectors and XPath if you feel motivated, although I haven't seen anybody actually use them. So, and then we have a transform. All right, and the transforms are basically just functions that take a node. That is the basic concept for what a transform is. It takes a node and does something. I don't even care what it does. Sometimes it changes the node, sometimes it doesn't. But the key is here, it just takes a node. This transform where I'm actually passing data to it, that's actually a transform builder. It's actually going to build a transform and return a function that takes a node that can then be used to do the thing on. All right, here's an example. All right, I have this static file. All right, it's my form.html. All right, it really is just first, last name, and a button. But notice there's all this junk. This is all the stuff the designer is really good at that I suck at. All right, this is the classes stuff, CSS that's pulling in from somewhere. All right. Now, if we look at the data, all right, this is my name, if you haven't figured that out. First name Creighton, last name Kirkendall. This is your first picture of Clojure. Yay. That's a map. If you notice, we have keywords, very similar to Ruby. But this is just a simple map that says, hey, my first and last name. All right, here's the cool part. This is actually a piece of InFocus. All right, and I'll explain. This def template says, go get this static file. All right? I'm actually calling this user form. I'm compiling it, which actually means I'm going to take that static content and I'm going to shove it into the JavaScript that I produce so that I can manipulate it inside that. I then have the data being passed in. This is the args. I then have selector, transform, selector, transform. Notice that I'm doing first and last, getting the first and last name from the data. And notice that in this selector, I actually am registering a listener for a click event that's going to do save user, some function. It's called save user. This actually was pulled partially from the app I'm going to show. And then I actually want to put it inside my live DOM. So all that happened off DOM. All right, I'm putting this inside my live DOM, and I'm actually going to append the form. All right, so all of a sudden this thing shows up. All right, this is the basic structure of how InFocus works. But notice that unlike jQuery in that, the transforms are sort of self-contained. It is, I'm taking in data, and the two data pieces I'm taking in are this data and the static HTML. And then I'm transforming that to create a new DOM that I can then append somewhere else. Okay? Now notice, at some DOM, selector, selector, selector with transforms. If we look here, def template basically reduces down to an at form. The reason why I have def there is because I can compile and do some optimization here. Because I have a compile phase in ClojureScript, I can do some interesting things. You'll notice there's a little bit of Clojure here, and I haven't gone over any Clojure. But you get the basic idea of what Enfocus is attempting to do. The key here is that it really is separating out things. And I will show you there. You can see first and last name coming from, we're actually setting the values here. So, all right, what do we get? We get this. All right? That's the result. Okay. These are all a bunch of transforms. You will see that a lot of them are very similar to jQuery. Even things like listen live. Or what do we call it? What do they call it now in jQuery? The live, it used to be called live. What's it called now? I can't remember. On. That's what it is. Like we have all the different event management. We have resize moves, some animations. I mean, in essence, we have a lot of the same things in jQuery. This is not jQuery is not running this in the background. This is all done either through Google Clojure or through my own stuff. All right. There are two different types of ways to get remote content. One of them you would use a lot. The other one you won't use a lot. One is called templates, rarely ever used. The reality is you rarely ever want to grab the whole piece of something. You want to grab pieces in order to build the app. So we have snippets. Snippets actually allow you to pass in a selector, and instead of grabbing the whole content of what the static file is, it'll grab a piece of it and say, I just want that little piece of it, and that's what I want you to compile into the JavaScript. All right? This is very powerful. The snippets are extremely powerful, and we'll talk a little bit about them when I get more to the app that this does. But the idea here is that with these snippets, again, I can combine them with data and return them back and put them where I want them. So I keep forgetting I'm not hooked up. Problem one, I'd say it's solved. This is where, and what I'm going to show you in this app in the future is I actually have a static prototype that is the input to the application. It's a fully functioning prototype. I can click through it. And if I make changes in that prototype, it will appear in the app. The app is completely separated from it, though. The app simply uses pieces and cuts them up, and we'll sort of talk about how it does that. Let's go to the next. All right, let's talk about problem two. Problem two with a web developer, as we have all, millions of people have attempted to solve. We have the front end and the server. They're two different worlds. All right? They're really two different worlds. As in, Java and JavaScript, even though the names sound similar, they are nothing alike. Ruby and CoffeeScript, even though they look similar, they really aren't alike either. Python, Dart's another language, Scala, LiveScript, TypeScript. There's tons of different languages over here, all right, that people have attempted there. But the ones that we use mainly have different constructs than the server-side languages. And part of that is to do because there's a totally different architecture in that world. Like over here, we are concurrent. Over there, you're single-threaded. You don't have concurrency. Over here, we are flow and request-based, although this is changing. And we'll talk a little bit about that. Here, we're event-based and callbacks. All right? And there's a great quote that someone wrote. Callbacks are this generation's go-to. Like if you've ever done callbacks and wired them all up, you real quick realize that, wow, I have dependencies everywhere. All right. This quote, you either hate one or the other. I hate the front end side, which is sad because I actually came from that side. I started out as a designer. Like I did print material back at Wright State University and started doing websites because I could draw. I quickly realized I am far better at the technical side than I am at the drawing side. There are people that are gifted, and gifted in ways that I can't even comprehend. And I've worked with a few of them, and once you meet those people, you realize you should not be doing this. If you want a high-performance team, you need that person to be doing it. So how do we actually unify the development practices across both worlds? I mean, how do we figure this out? I mean, we've got different languages sitting over here. We've got different architectures. I mean, the thing that kills productivity is that context switching. Like, if I'm an expert, how do I actually, can I be an expert in front-end development and back-end development? This room would probably say no. I would actually agree with that for right now. But, all right, step one, unifying the language. All right, this is a big piece because that's 90% of the stuff that we do is all about the language. Like, do we know the best way to actually architect and build something in a given language? If we unify the language and we have common constructs, that helps a bunch. Node.js is a perfect example of this. I mean, the reason why Node.js is so nice is because literally you can use your concepts that are sitting on this side of the fence over on this side of the fence. And you don't have to do that context switch as hard. All right, but we have a thing. We have Clojure and ClojureScript, Java, wonderful GWT, or failed GWT. I don't know which one you want to think, but GWT that Google did, it takes the opposite approach. Instead of, it actually compiles Java into JavaScript but hides it all. You have F#, and F# has this thing called Pit, which actually will compile Python. Ruby has Opal, Scala, Scala.js. There's actually a lot of ones that compile to Ruby, but no one ever uses them. I'm not really sure why, but it's interesting. Okay, let's talk about Clojure and ClojureScript. All right, you've seen a little bit of Clojure, but I've sort of hidden most of it because it was inside InFocus. So this is sort of a basic translation. I'm not going to teach you Clojure today. This is more about concepts than it is about anything. All right, we do not have enough time for me to teach you Clojure. But when you look at the code, you kind of need to understand what you're actually looking at. So like a def statement, that's your var. It's slightly different because we have this concept called namespaces. So there is no such thing as a global. Like we don't create globals. So if you left var off here, this would be a bad thing. You can't do that in ClojureScript. This is Clojure. This is defining a variable in JavaScript. This is defining a function, and basically it's a function that just concats x equals to x. All right. This is how you do it in JavaScript. All righty. Anonymous functions. In JavaScript, they look like this. We have two different ways to do it in ClojureScript. We have just the standard sort of, this is an anonymous function, and then we have the shorthand notation. This is actually used a lot. I actually tried to avoid it in most of the code because I was showing it to people that may not be familiar with Clojure, because this can definitely throw you for a loop the first time you get into it. But both of these two functions basically do the same thing. The percents are just what parameters you have. The plus is the function call. All righty? Okay. Clojure and ClojureScript. These are the things that are not in JavaScript. All right? We have namespaces. Namespaces are awesome because they basically isolate components. In JavaScript, you don't have namespaces, although we've tried many ways to try to get namespaces, either by doing like Dart, which is the whole long name thing. Google Clojures uses it, where you do ... and you create the sort of sub object hierarchy. Or you wrap things in closures to try to get that so they're self-contained in some sort of scoped environment. Namespaces get around all that. It means that you don't have to have any of that funkiness scoping. Like, it allows you to have built-in components, and I'll show some of that as we go there. Persistent data structures. Clojure is a functional language, and one of the key parts of functional language is immutability, meaning things aren't changed. All right? Well, persistent data structures give you an efficient way to do that. It basically means anytime I change this object, I get back a copy of the object with my change. Okay, well, persistent data structures are really cool in the fact that they're efficiently doing that. They don't actually make a full copy of the object. They have a tree structure underneath that basically changes the pieces that they need and then returns you in the new tree. So this is very powerful, and a lot of languages are adding actually the persistent data structures from Clojure into their language. Scala is one of them. I think even F#'s in the process of adding them. The second thing is controlled mutation. Because the base data structures inside Clojures are immutable, there are sometimes we want to change something. But we have to do it in a very controlled manner. Right? And this is important as we get to the next thing, which is concurrency. All right? Because if I don't have controlled mutation and I add concurrency to the picture, things can go a little haywire. And particularly in JavaScript, that's one of the biggest challenges of why they can't add threading into JavaScript. It's because the mutation alone could kill you. We have this concept called watchers, which basically detect if changes happen, a la Backbone. It's just built into the language. Like we can look at things and say, all right, notify me when that changes. All right? So built into the language, we have something akin to the way Backbone structure is for models. We have macros. This is huge. And we'll talk about in a second how huge this is. Like, there is no way that I could have done InFocus and made it efficient without macros. Because part of being able to pull in, macros gave me a way in compile time to get the information I needed to actually optimize and inject the snippets into the JavaScript correctly. All right? Macros are extremely powerful. There's some, they can be. But you'll see is that, again, with great power comes great responsibility. All right? You definitely, the first thing, you'll notice that InFocus is actually InFocus 2. It's actually been out for several years. It's InFocus 2 because I removed almost 90% of the macros that were in the system because they weren't composable. So I figured out a way to do them without doing macros, but there's still a core piece set of macros for the def template and def snippets that have to exist because there's no other way to do them. But everything else was moved off. So I don't have. Destructuring. Destructuring is really cool. It's really just a way to shorten code. It basically takes the base data structures and say, since I know the base data structures and how they work, I can give you a shorthand for a way of assigning variables. So I can destructure that and make, say, OK, x equal this, y equals this, if this array is in this structure. All right? Think of it like positional assignment for arrays, key assignment for maps, but it's all in a very terse syntax. Keywords. Keywords come from Ruby. You've already seen them a little bit. They're mainly used for maps and for sort of control structures. Similar to the way they're used in Ruby.
So these things are in Clojure and ClojureScript?
Everything. Like one thing you're going to realize, and we'll talk about it heavily, is ClojureScript is Clojure. It's not some pseudo Clojure. It's Clojure. It has all the same data structures, all the same control structures. The only difference is in that concurrency area, because the browser doesn't have concurrency. So that's where you see a difference. But everything else about the language is the same, including how you structure code, which is a big deal because we have nice ways and best practices for structuring code in Clojure. They translate directly over into ClojureScript. All right. How powerful is it? They were able to add concurrency into the browser as a library. Basically, they implemented green threads, and that's what I'm going to show next, is core async added a picture, added a piece to this puzzle that is huge, which I think many other languages will actually follow that are compiled to JavaScript. The reason why it showed up first in ClojureScript is macros make it much easier than it is going to be able to integrate it into any other one. But the idea here is they, in essence, turn code into a set of threaded operations in the browser. And they added a scheduler into the browser. It's not part of the base language. It's actually a library. Now, if you think about how what's actually happening in the background. For those that know continuation passing, in essence, they're translating the code into continuation passing style so that they actually have a continuation and scheduling it. All right, so step 2 to solving problem 2 is unifying the architectures. It's one thing to unify the language, but if the architectures are completely different, I still have to context switch hard. I still have to think, how do I actually develop in this world, and what are the best practices in this world, versus how do I have to develop in the server-side world? You still have that struggle. So Core Async added concurrency into the browser. I now have concurrency on one side of the fence, and I have concurrency on the other. I actually have the same architecture. I should be able to build a component-based system that actually would utilize that. All right, give you a little introduction into Core Async. All right, this is a little piece of Core Async. This works both in JavaScript as it does in Clojure. There's no difference in this code. All right. In fact, you'll see that my entire large piece of my code that uses this is cross-compiled to both setups. So we have a channel. All right. Core Async is based off of Go, the Go language's channel concept. So if you think about it as little message buses where I can pass channels in. For those of you who use message systems like RabbitMQ, this is internal RabbitMQ. And it has some of the basic patterns like broadcast, multiplex, those type of things that we're used to in messaging. Interesting thing, okay, we define a channel. We have this Go block. This is where the magic happens. That Go block is what's translated into green-threaded operations. So it gets ran off asynchronously, and each operation gets ran off asynchronously in it. So it walks the code and figures out, how do I make this so that each operation can be ran independently, so that if I have to stop any operation, I can do and pick up where I left off, right? Which is in essence what a thread is. Like when you actually switch like thread context, the idea is the processor sitting there and it says, wait, I'm going to stop this thread and I'm going to start this one. Now I got to go back to the same place. Well, JavaScript doesn't have that concept. So what this adds in is that concept, is that I can go back to where I left off. All right? And that's important because inside here, this little thing, this is read. All right? So I'm reading from the channel. That's a blocking operation. Like there is no sleep in JavaScript for a reason, because you stop everything. This doesn't, but it's the same as a sleep. In essence, it blocks this thread of code until there's something in that channel. This is sort of the beginning to separate the idea of callbacks. The caller is tied to the receiver. This is separating that out and giving you channels to pass things across where the caller is no longer tied to the receiver. All right, so we're printing out the message. We put test onto the channel. This is actually writing to the channel. There's actually a couple different ways to write. Notice this is outside the Go block. This actually fires off asynchronously because it has to. Meaning that when you write this, it actually goes and says, oh, I'm going to schedule that. It doesn't actually put the thing on. It actually schedules the put. All right. So here are the two things. There's lots inside Core Async. I'm only going to show you the bare minimum to understand the code and to understand the concepts. So we have reading from a channel. That requires inside a Go block because this is a blocking operation. All right? So we can't do it outside a Go block. All right? This is taking from the channel. It's done asynchronously, and it has a callback function. All right? So if we're outside a Go block, this is how we would take from the channel. Writing to the channel, same thing. This is a blocking operation. If there's nothing to receive and there's no buffer for the channel, because channels can have buffers, this is a blocking operation. Like if I'm writing, something has to be receiving. If I can have a buffer, I can give it 100 things and I can write 100 messages, but that 101 message, if I don't have anything reading, I'm going to block on it. Other one is putting a channel. This is also an asynchronous operation. It's outside the go block. All right, some code. All right, this is actual code cut and pasted from the app. This is actually inside our testing, the testing area, and on the front end. The app is actually unit tested, the front end code, and there's some cool things in it, so I thought I would show you. So we're inside a go block. All right, we have some channel here. Don't worry where the channel is. All right, but there's some channel there that I actually pass some message init to. All right, but look at this. I have this funky timeout 100, and I'm reading from it. Well, timeout actually is just something that after a certain amount of time, it'll then pass a message. Okay, so it actually waits. This blocks for 100. This is sleep. In this line of code, this is sleep. This is actually executing in the browser. This is the front-end test code. So I pass in the init, but because everything's running asynchronously, I actually have to wait a little bit before I can actually check the changes to the DOM. All right? Now, how I'm doing this, I'm actually doing it in PhantomJS. How many know what PhantomJS is? All right. LinCLJS, the actual build structure for this integrates directly into Phantom, and it makes it real nice to do these, and I'll show you some of it. Text from login button. So if you notice this little from, this is also from InFocus. Where I have transformers, I also have the opposite side of that, which is called extractors, which basically, instead of transforming the DOM, these get information from the DOM. All right, so there's a whole bunch of these, like get text, get property, get data, like the jQuery data stuff. So I'm asking from this, I want this text. So I get the text, and I check to make sure that it's the right text on the button. All right, so that's a test. This is assert. What I'm basically saying is that init actually triggers an event to add the login page to the live DOM. Because I add the login page, I then need to check, make sure it's there. So I then go check to see if my button's there. Okay?
So did you say is like assert?
Yes, is assert. I'll show it a little more detail later. Again, we have our transform at, and then a set of login username, login password, login button. I set the property to a specific value. All right, I set the value to U1, P1. I then dispatch a click. So I'm actually dispatching off a click to it. All right, this is just like for those that have done testing, this is basically I'm just simulating a button click. All right. This is the namespace. This is just saying basically, I took off the namespace headers on here, but I basically have Dominia events tagged to DE. All right, and then dispatch is a function that's in there. But I'm dispatching, basically this dispatches the thing. Notice this is that anonymous function. So this is a custom transform that is an anonymous function that takes a node. All right, so when I get to this and I find this object, when I do my transform, instead of transforming it, I'm actually saying, click it. All right? This is nice because it allows you to customize. Extending InFocus is nothing more than writing a function that takes a node. For those that have written jQuery plugins, which I've done quite a few of, that's nice. jQuery's not so nice. Like the complexity of a jQuery plugin has a little bit of overhead. It's very nice, and he was brilliant to come up with it in the thing because no one else figured out how to get JavaScript to actually chain those things nicely. He did, but in this one, because of the functional nature of it, and because of things like protocols, which allow me to extend objects inside a namespace, I'm able to actually take in functions as transforms. All right, and then I also have another assert that just basically, this one checks to see if the actual login message gets sent. All right, so I'm listening on another channel. So sometimes I click this button, something happened, and I say something's going to come out of this channel. All right, this is the beginning of sort of a picture of what this architecture could be.
How did you know it got dispatched to that channel with the namespace P?
How did I know?
Yeah.
Well, because I architected it. I mean, in essence, this timeout if nothing appears here, this little alts thing basically reads from 2 different channels, or as many channels as you want, and takes the first one that replies. Okay? Because I have this timeout here, it's going to reply after 100 milliseconds. I know that it takes less than 100 milliseconds for the DOM to get updated. Okay? So this one should reply almost immediately. If it doesn't reply, this assert fails because this doesn't return back a login message. All right, does that make sense? I see a few people scratching their heads. Alts is very powerful, and you'll see it. It in essence allows you to basically multiplex a bunch of channels into one. Timeout just happens to be a channel in and of itself. All righty, unified architecture. So now I have concurrency on one side and concurrency on the other. I can actually design an architecture and split across both. Is this the best architecture? I don't know. This stuff is brand new. 3 years ago, I sketched this architecture out and went about trying to create it. InFocus was a piece of it. I attempted to port Lambda, or Aleph, which is a server-side Clojure channel library, into JavaScript and failed miserably. For one, I'm not Rich Hickey, and it turned out to be much more difficult than I expected. But Core Async provided it for me. I mean, it actually provided that channel. But this was the architecture I sketched out 3 years ago. And the idea is I have event buses on either side of the client and server. All right? So we pass messages back. It's not like request response. We're message passing, like we're wiring up an enterprise architecture. All right? We're message passing between systems. And then we register components onto this event bus that can listen on for different ones.
Is the transport always WebSockets?
It can be anything. It can actually, you can set it up to be pull, like long polling and stuff like that. I chose WebSockets because it was the easiest to implement at the time, because this took me probably around 15 hours to do, and it's a lot of code. So I chose WebSockets just because of speed. But you could set up long polling. This is, because of the way the channels work, any way you can get the messages across. The key is the server has to be able to push messages, because it has to be able to send messages. Not every app requires that, but the architecture does to work right. Again, we have components sitting on this side. Components are just wired into the event bus. They get to decide what messages they care about, and they get to progress what messages they care about. All right? Same thing sits over here. There is no difference between this side and that side. When I mean no difference, I'm about to show you the code is the same. It's because it literally is cross-compiled between the two of them. You notice here the prototype is nothing more than data that's brought in by those components, just as the database is brought in by components on the server side. All right, the prototype is brought in by components on the client side. It's just another data source. Right. Okay, now I'm going to talk about the Chatbox demo. Chatterbox. I basically wrote a chat app. It's actually a very cool chat app. It looks exactly like this architecture. All right. It basically has the event bus. I'll show you the code for the event bus. It has how the component structures wire up. But what you'll notice is these little pieces are composable. In fact, when I wanted new functionality, I created a component and wired it in. I didn't have to do any magic. And the components are completely independent of each other. All right, this is the entire code for the event bus. Everything to do with the event bus. All right, this little protocol, this is basically an interface definition. I now have something like interfaces over in JavaScript. All right, called protocols. So I say I want a component that'll take init, has an init function, has an accept message function, and has the ability for me to get the channel to write the message to. Okay? Notice the init takes an out channel. The out channel is what the bus says, here's my channel. you write to that when you want to send me a message, and give me your channel so I can write to you. All right? So it's a basic interface. I'm basically defining how these things talk. The event bus basically goes and says, all right, I'm going to create my channel. So I just create an internal channel inside the event bus. I go through and I tell all of my children. This is just a list of children, components. I tell all my children, here's my out queue. You can start writing to it. All right? I then sit and I put this go block. Again, this is asynchronous. So somewhere sitting out in the ether, this little thread's running and says, all right, what I'm going to do is I'm going to sit and I'm going to listen on my out queue. All right? I'm going to sit and listen on my queue. And when I get a message, I'm going to broadcast it out to my components if they'll accept it. Like, if they don't accept that type of message, I don't want to broadcast it to them. The reason why this is actually is more of a performance reason of why I didn't put that inside the component while I put it inside the event bus is because this is creating tasks each time that you send a message. And this keeps it all at least in the same thread. All right, we don't want to create a new task for this. So it's cycling through all the things, and it says when my component accepts this message, I'm going to actually write it out to its channel. Super simple. All right? Tiny bit of code. Very powerful piece of code. All right? This just says I'm going to return the out channel when I'm done. Okay? All right. The anatomy of a component. All right, it's real simple. We have setting up a component. What's my setup? In essence, I have to implement that interface, if you think about it. I have templates and snippets. If this is only on the client side, do I have this step? All right, this basically says, all right, on the server side, this would be where I have data coming in. For what I'm showing you here, this is templates and snippets. It's data from the static file system, whereas it's data from a database elsewhere. I have action functions, which are really just the functions to do stuff. And then I have dispatch, which basically dispatches out to it. So if we go, set up a component. All right, here's the basic code for setting up a component. This is important. This valid types here, that basically says here are the messages I care about. Because this is how I say defining my accept messages is based off of this list of things. Every component looks the same here. There's no difference in how the components look. In essence, I have all the valid types. I set up the accept message the same. This could actually be completely abstracted out into a component builder. So I don't have any code inside the component for this. Right now it's inside the component because I need to show it in order to explain it. But in a future iteration, this would all be refactored out. All right, so I create my init where I basically am setting the out channel. This is the controlled mutation. Because I'm in an asynchronous world, I'm actually resetting an atom, which an atom is an atomic operations. Basically, anytime I reset it, it's guaranteed to be atomic. Meaning no two threads can be messing with it at the same time. That's important because we now have concurrency. So we need that. And then I call setup. All right. If we look at templates and snippets, again, I am actually pulling in. This is for an error. Like I have an error component in my front end that actually pulls in the look and feel for an error message. And anytime an error message gets thrown onto the bus, which you can see here would be anytime basically security, login failure, user error, or a message error. So anytime an error gets thrown onto the bus, this component is the one that responds. Error handling is not even in the other components. It's all centralized into here. All right, so here's what I do. I actually create a snippet called error div. It's compiled, and I pull it from the static file system, just like I'm pulling from a database. This little snippet, this is the selector here that actually says this is the piece of that I want. All right, so I can use CSX selectors in snippets to say, I just want that little piece. That's how I cut it up. It'll take XPath selectors. It'll also take custom selectors if you wanted to trace the DOM yourself. I then error div, I want to hide this to start with. So I set the style, display to none. Again, you'll notice the way this is structured. Like, in essence, we have our selector and then our transform. All right? So I'm saying, give me the error div, but I don't want to see it. The reason why I say I don't want to see it is because the prototype certainly is not going to hide it. Okay? Because it's a prototype. Like, you want to be able to see what you're actually doing. All right, action functions. Okay. If we want to, first thing this error thing, this is all of its action functions. It only handles things like initialize me and show an error. That's all it does. It either initializes or shows an error. So initializing basically appends the error div, which is the snippet that we did. It appends it to the body. All right, it's hidden, so you can't see it. It's not displayed anywhere, but it's now part of the live DOM. I then register an on-click event for the close button. All right, I register an on-click event, and I set the display to none. So once I display it, I'll have a button to make it disappear again. All right, really, really simple. All right, but it's all self-contained inside this component. It's just listening to messages on the bus. All right, I want to go to show an error. All right, when I show an error, again, I want to I take in a message. I don't care where that message is coming from right now, but I take in a message. I want to show that message to the user, and I then want to display the actual error div. So I remove the none off of it. All right? So I'm just basically popping a little screen every time an error happens. Doesn't matter where the error came from. The error can actually come from the server. Dispatch. Basically, we take an in channel, we create a go loop, and we basically listen for the message and then figure out what to do. Some of them have much more complicated. I actually use core match, which is a matching system similar to an ML style match setup to actually match most of the messages. This was a really simple one where I could use an if statement because I only have two messages. I have initialize and error. So if I get initialize, I call initialize. If I get an error, I then call the error. All right, notice I have my little debug statement there just so that I can see it in the console. All righty. The next key part of the architecture, though, is all that's well and good, but what about testing? I mean, most people in here probably do a lot of unit testing. At least historically, the group CinciJS has been fairly big on that. This is sort of the anatomy of how this testing works. Because the architecture is the same on both sides, guess what? The testing's the same on both sides. And the tests look the same. I mean, in essence, we set up a component. Components are tested as units. All right? What's neat is the client itself is what's called a subsystem, and it's a component. So you can test the whole client of this and the whole server without any HTTP involvement, just through unit tests. So each component is self-contained. So the first thing we do is we actually create like our login view component. So we have a login view component that we want to create. We want to basically init is that we're basically doing what the event bus would do. We want to create the setup for the channel so that I have an input channel and an output channel that I can now write and read from to test this. Notice here on the server side, it's the same code. There's no difference in how the code structure was on the server side and the client side. In fact, things like the event bus and the code that eventually this will get refactored where I pull out the thing will all get cross-compiled. I'll have one file that goes out to both of them. Right now, the event bus and the whole structure for it is. But here, we actually set up the channel. We create user components. We init them, get the channel output. Same thing. No difference between how you do this on the server side and how you do it on the client side. All right, setting up the channels. In essence, here's our channels, our input-output channels for the login view. Because we're only dealing with one user, login. If we go over here, we're actually testing the user functionality here on the server side, so we have multiple users getting created and multiple channels, okay? Because we want to test the interaction between, this is a chat app, so we got to test, oh, can I talk to this? If I log in, does this person say left? That's all right. All right, defining asserts. All right, this is the cool part. All right, we've seen this code before. This is the login button. Same code. We are able to do sleeps. We then have our asserts. This all works. One key note, asynchronous testing, very hard. No testing suite works well with it. I have spent a lot of time thinking over the last week on how to actually stop that, to fix that. But in essence, I get my asserts just fine. What I don't get is the summary report, because the summary report's done, printed out long before any of this actually executes, because the whole block gets executed asynchronously. Like this whole thing's inside a Go block. So you get the summary report that says, I didn't have anything to do. And then all of a sudden your asserts show up. That's, oh, you had lots of failure. You were just a boatload of fail. All right, server side looks the same. Literally, it's the same basic structure where I'm basically writing to the channels and listening for the messages back. On the client side, you'll see that I'm actually looking also at the DOM and using InFocus to basically set things and stuff. But on the server side, we don't do that. All right, whoops, going the wrong direction. All right, anatomy of a subsystem. If you think about a subsystem, this is like your client and your server. It's just a component, but it's a special component. It's a component with its own internal event bus and subcomponents registered on that event bus. All right? So again, we just have setup component. I'm going to move really quick. This is what it's listening for. All right? So I'm saying I'm only accepting these messages. So the client says, I don't give a crap about anything but these messages. Because I'm a component, that's what I do. I tell you what messages I will accept. We then have an internal component that basically says, hey, when I'm listening on my internal bus, these are the messages I want to listen to. And what it does with those messages, if things come from the outside, I stick them on the bus. If things come from the inside, I stick them out. So I basically get an input-output queue now to an entire subsystem, just like a component.
Can you go over what reify does real quick? That's sort of important.
Oh, yeah. Hold on. I'll go back.
All right.
This is basically creating. This reify is just how I created a component. Because I'm implementing that interface, this is basically an inline implement. I could have actually created a type and extended the type, but I'm just saying, no, I'll inline this and create this just as a return value. All right, that's what reify does. All righty. Setting up the event bus. Again, the event bus is really, really simple. It basically just takes, the event bus takes all the subcomponents that were passed into the subsystem and conjoins it with the internal component that it's going to register itself on. All right? That's the whole architecture. So let's actually, well, that just locked up. But that's OK, because it's done. All right? It only goes to something that says, let's chat. All right, so we're going to go out now to the chat application and see how this thing actually works. And I'll show you how the messages are actually going. All right, so let's escape out of here. First things first, let's make sure this is the static. All right, this is the static demo. All right, I say it's static because I can actually click through to it. I don't have to provide it with anything. But this is basically the look and feel of the app. And I'll explain each of these pieces, but I'm just sort of clicking through so you can see that this is basically a static, just static pages with links so that all the look and feel can be defined. All right, notice there's an interesting thing like this is green. That means I'm waiting for a message. Because I have an active conversation here, I then have, when someone sends me a message, I need to notify them that they have a message. So this guy actually says, I have messages, so click on me, please. All right. Again, we have the send button, log out. We can actually create a new user. In order to sign into the system, you actually have to create a user. All right. People can see my IP address. All right. Whoever has a thing can actually hit this thing. All right. So we have our static thing. Again, that's just data. That's the prototype. I actually read the prototype off of the disk and manipulate it to make it dynamic. and here's the outcome. All right, and just to make sure that there's no funkiness, we're going to hit enter. All right. Okay, so first things first is let's create a new user. All right. So, oops, no, I'm not going to put a picture in here, but it will show up as a picture just because I don't have a picture URL. All right, so I create a user. All right. Ben, do you have a user created?
I do.
All right, let's sign in. If somebody else would like to sign in, that would be awesome too, because it's much better if 3 people do it, because then you can see the messages. But all right, so I'm signed in. Are you signed in?
I am signed in, but I think there may be a bug because neither of us are showing up.
How is that possible? Can you log out? Just log out. Are you logged out? Can you hit refresh?
Yeah.
Awesome. Somehow we're not connected to the same thing. But that's all right. All right. There you are. All right. I don't know what was going on. All right. So Ben's on there. All right. Go ahead and send me a message, Ben. This is the cool part. Did you send a message?
Just hit send.
Notice that I got a notification. This is the push feed. All right. Ah, look, there's another one. Like I can go, let's see what Ben's put. All right, howdy. All righty. So I can flip back. This is fun. All righty. What in the heck? What happened there? I hit something. That's going to be a problem. All right.
You're back on your status.
Somehow I've got all kinds of things. Of course, live demos. I love them. They're awesome.
Back on static.
Yeah, I realize that now. All right, that means that what probably happened is I didn't replace the href on the form. I changed the on click event, so it probably would work if I clicked, but I hit enter. So that's all right. I have enough error handling that if I do get kicked off, I should be fine. All right, we got lots of people on. Wow. We got all kinds of people. All right. I've lost your message, but I can actually send Ben a message. Can you send me another message?
Yep.
All right, look. See, we can chat with Ben. Someone else. Let's see. Jeff, how you doing? Oh, let's see. What's Phil got to say? Hello. Hi. But basically, you can see that we basically have a nice little chat app, all right? We can do things like updating our profile. We can log out. We can do that. One cool thing is that if you log out, it also vanishes here. Like it again, those messages are passing back and forth between everything, all right? Because the event bus is sitting there taking it back and forth. All right, so if I log out, you guys should all see me disappear. Did you all see me disappear?
Yep.
Yay. All right. So that's sort of the whole setup. All righty? That's all I had. Yay. I can give you questions. All righty. I haven't had any pizza, so I'm going to have to. Oh, it's 106.
First
I
you have to
took
answer
a
questions.
little over there.
Yeah.
But all right, questions.
So I don't know if this concept makes any sense in the ClojureScript world, but one of the things that was awesome about Tapestry and Angular is the concept of two-way bindings. Does that have any analog?
Watchers.
Well, watchers
When-
are more like backbone and augment
Yeah,
yourself
that's-
kind of a thing. Whereas
When you
two-way
say bindings, you're
so like Angular will keep, if I bind an input to a model object, it'll keep that in sync if there's changes on either side automatically.
no. In essence, what you would end up creating is you create a little handler that would end up doing that with selectors. Yeah, I mean, there's definitely not thing, in part because I'm viewing that prototype as data. Although I'm sure you could actually wire something up.
Fundamentally mutable.
It is. I mean, it definitely goes against some of what I view as there. I mean, you're wiring something up. In general, I try to avoid that to some extent. I'm not even a big fan of watchers because the message passing is a much more efficient way to sort of manage things because you can basically self-contain stuff. I don't care about watchers inside a component. In fact, if you look at this is the ultimate object-oriented. I mean, we're talking full encapsulation inside these components. They're self-contained. They don't even have a concept of data inside other components. Like, all of them listen to the login success so they can get a reference to the user object. I mean, it's true data encapsulation and message passing. So it's the old school OO before Java got hold of it.
Is it possible to integrate with like what front-end frameworks like Angular, Ember?
Yes, ClojureScript definitely can integrate. In fact, there's a few people that have written libraries to actually integrate with I know Angular for sure. There's a nice jQuery wrapper. I mean, obviously I'm not rawing that, but but there is a really nice jQuery wrapper, and they did a good job on it. There's certain things about jQuery and other things because this thing is compiled and highly optimized because it uses the Google compiler to basically optimize the thing. Certain things like jQuery and that can be done, and they can be done very nicely, but they enlarge the size of what you got to download. Not a huge amount, but enough that it would be better not to.
I'm trying to get a feel for how complex the apps that have been working with this, the ClojureScript in general are, and the debugging story and how that is as far as Chrome dev tools and that kind of thing.
I use the Chrome dev tools heavily. They're working on source maps so that we can map directly back to the source. Those are not in place yet. So there is still, I'm looking at JavaScript. In essence, the Google compiler will output. But one thing that you do have that you can't comprehend unless you're that is I have a REPL directly into the browser. So I can do a lot more debugging through that REPL than it is just like the console inside the Google DevTools. I mean, so no. I'm copying Clojure. It's getting compiled and shipping back and forth. In fact, if I could show you Light Table, which actually puts Chrome inside the setup, and literally as I change the code, I hit a keystroke and it automatically updates over here. And I get feedback from the developer on which things. That's the only thing that has the integrated sort of testing thing and debug. I'm not an expert in Light Table, so I didn't do that. I mean, I use Emacs mainly for Clojure development, although I've played around with Light Table a lot and I like it and may switch, but it's sort of mentally hard to switch. But it's hard, especially for Lisp.
Production apps.
For production apps, there's quite a few people. Actually, InFocus is used on several production apps. I'm trying to think if there's some that you would know. I mean, one of the apps that didn't use InFocus but uses ClojureScript that just got highlighted in the New York Times is one of the best infographics. It's actually a mobile app that uses HTML5 and ClojureScript. That was done by Kevin Lanik. That actually uses Angular. Like he wrote some stuff with Angular. InFocus is used. There's a company out of South Africa that has used InFocus a lot and has recently set up. There's a lot of startups. I mean, it's the same thing with the early days of Ruby. Is Clojure is being used by a lot of the startups. So whether you know them, they would love you to know them, but not all of them are even production ready yet. This is bleeding edge. ClojureScript's not as bleeding edge. It's still fairly. It's very stable. Like you don't run into problems with ClojureScript. Core Async, I had to patch to do this presentation. So it is really bleeding edge. Like it's like cut yourself bleeding edge. InFocus, very stable. It actually works back in IE6, even though my eye twitches because of it. I spent a lot of time trying to figure out how to get that to work. But
aside, I mean, having done a little bit of Go, not a whole lot, but the channel implementation looks like, I mean, it looks like Go. I mean, they use some different keywords here and there for like your joins across, like I need whichever these come back first, but from your channel for doing timeouts and whatnot. Those patterns are really, really common in Go. So if you want to play around with some of this stuff, that's another language that you could totally look at as like a way to sort of understand where these concepts came from.
There is a compiler to JavaScript for Go, although I do not think it really supports the actual asynchronous stuff, which is funny because it sort of defeats the purpose of Go. Because the language, I mean, Rich Hickey he flat out says, this is his way of stealing. I mean, he admits that he really likes the way Go. I mean, it really is a cool way to think about apps. I mean, because you think in components and message passing, and not in sort of how do I interweave this stuff.
It's also a perfect example of that difference between concurrent design and parallelism, right? Because it is by definition not parallel on the browser because it's single-threaded, but you can still have a concurrent design that allows you to reason about the program.
Yes. Yeah, that's huge because I can use those same design patterns across the board. And some of these design patterns have been hammered out. I mean, they're used all over the enterprise world for things. We just don't use them inside the little apps or the web apps, which is funny.
You might be able to get some parallelism out using web workers. I know this spec isn't well supported yet cross browsers.
Oh yeah, I mean, I wouldn't be surprised if that stuff comes at some point, of course. Yeah.
I think that might be how they're doing promises.
Yeah.
One thing to note, there is something really cool about these that is so much cooler than promises. I can't show you, but when you read, if you pass a JS error or an exception to it, it propagates the exception to the caller, to the reader. So I get error handling so that literally asynchronous error handling, which just even conceptualizing how that functions. Yeah, I'm like that's huge. I got to wrap my head around how to use it correctly, but that's huge. The idea that now I can propagate errors, even in asynchronous events.
So I guess the only other comment, it seems like you get away from sort of the direct coupling through callbacks, but it seems like you get some sort of implicit coupling through like message naming and stuff like that. So if you have to have propagated message names to both the bus and to sort of the components and what they care about, you run into the case where we've sort of coupled them through what messages they accept or anything like that. I guess that was just an aside as more one.
In essence, what I did was I created a single protocol thing that stored all my protocols that was cross-compiled across them. That basically said, here's how you create all the different messages. You are definitely coupled to the protocols. I mean, there's no way around it, really. I mean, the messages that are passed are the data. I mean, the thing is, by definition, you're coupled to the data, and the messages are the data. I mean, that's the thing. There's no real way to sort of separate that out. What we are trying to do is separate out the caller from the receiver so that the components can be completely isolated. Like this.
That was I hadn't quite thought of it that way, so that was a good explanation. It is the data itself that you're. Got to agree on both ends, right?
Yeah. Now, what's really cool is I literally could swap out just the chat component view, the chat view component, and the message component on the back end, and replace them with a to-do app, and I'd have a to-do app. Like literally just wire them in. Because the way the structure works is that chat controls everything about that chat window. It has no concept of login. It doesn't have anything to do with user. It controls everything about that chat window. And if I wanted a to-do window, I could control everything about the to-do window.
Do you have pointers for if you wanted to build a Hello World app or how to get started at doing this kind of stuff?
Yeah, there is this tool called Lanigan, okay, which is it's basically their version of Rake, or Ant, or Maven.
What is it?
It's called Lanigan, which is the guy that's afraid of ants, which is kind of funny. He got. It's a build. It's basically a build thing. It's called Lin, probably. It's Lein, but it's line again. That's how you pronounce it, right? I'm not doing it wrong. But you can literally download that, go to your command line, go line new Enfocus-template, and you'll have an Enfocus app. It'll actually it'll be a full functioning little app that'll actually allow you to manipulate things in that. And
I downloaded it the other day. It was really nice. And you should show on your website.
Yeah, it's in the presentation. But if you go to Kirkendall at .github.io/Enfocus site. All right. This is Enfocus, and it has a quick start guide, and this is how easy it is to start. Starting a new project, that's it. If you want to add it to an existing project, that's one, but this is it. Literally, it's one line. It starts it up. You go in here, and you just run the server. It'll automatically pop up your browser, and you'll have your app sitting in front of you.
We have some nice code examples in there.
Yeah.
The various stuff.
So there's the thing. In here, every single thing of how you do things is documented. So if I wanted to, listen, I explain how each thing works. All the transforms are documented in here. So how content works, how we replace content, and different things. And it shows you the actual code that was actually running in each of the things. So a lot of work went into this. To make all the documentation, to make it easy for people. Because, that's one thing that I struggle with some of the things in Clojure, is it's a new world. So not everything's documented real well. So I put some effort into making sure this was at least documented.
I think the hardest thing I've experienced so far was getting the REPL connected to the browser. There wasn't very good documentation around it.
Yeah, I agree with that.
Yeah. I'm trying to think. There is an awesome tutorial out there called Modern CLJS that goes through everything about ClojureScript. That really he did an awesome job. He's actually working on an Enfocus tutorial. Is the next thing that's supposed to come out on it, because there's already 14 tutorials. So his next one is that, but it literally goes through everything, including how to do unit testing. What's really cool is the testing is identical on both the server and the client. So it's already built in, and he shows you how to actually wire it up so that you can get Phantom.js to basically do all your unit tests. It's impressive. He did a good job. I used it in order to do some of this on how to do the Phantom.js stuff.
So are some of you guys already doing ClojureScript?
Well, I'm actually working through the modern CinciJS.
Oh, okay. Okay, I wasn't curious. I was just curious based on previous questions if you guys had really done anything in anger with it.
No, not yet.
No, okay.
There are three main libraries for DOM manipulation that if you do play with it, one is Domina, Enfocus, and
Domino, I think.
Jack, Domina. I call it Domina, but and then Jack, which is the jQuery one. If you think of Domina is much closer to jQuery, whereas Enfocus is sort of a higher level abstraction for how to do transforms. I also help run that too, because that's sort of the basis underlying Enfocus. So that's also what's inside the ClojureScript book. The guy that wrote the ClojureScript book actually wrote that with a group of us.
Which ClojureScript book?
I believe there's only one. There might be a new one.
Frank wrote one from a number of years ago.
That's Clojure.
Oh, ClojureScript.
Yeah, there's only one book on ClojureScript, and Luke is who did that. He's actually swamped. That's actually why I'm helping out with Dominion now, because he's beyond swamped. All right, more questions? Was it a fun time? All right. Other than the technical difficulties, we did all right.